Hi guys, in this video we are going to discuss reverse in range. Okay, so basically what this problem is, basically we are given a linked list and we have to reverse all the nodes present in between a range. The range is provided by the user. Let's say we are having a linked list 1, 2, 5, 8, 0, 13, 14. Okay, we are having this linked list and range provided is 2 to 4. 2 to 4. So one thing to remember is the indexing. The indexing of this linked list is starting from 1. Okay, not from 0. It is starting from 1. So 1, 2, 3, 4, 5, 6 and 7. This is the indexing. Okay. We have to reverse all the nodes from 2 to 4. So 2 to 4. We have to reverse this. So what will be our linked list? 1. When this will be reversed, 8, 5 and 2. Understood now? We have reversed these three nodes. So 8 will come in the front, 5, then 2. And rest will remain the same. Rest will remain the same. Understood? So this is what we have to return. We have to return the starting point of this new linked list. Okay. So we know what we have to do, but how we have to do, we don't know. Okay. So before starting the solution, I will suggest you to watch the previous video in which we have discussed how to reverse a linked list in k groups. Okay, k groups means basically when k is 3, let's say k is 3, so we have to reverse this linked list in k groups. So firstly 1 to 5 will get reversed, then 8, 0, 13 will get reversed and 14 will remain same. Okay, so I will use the exact concept as I explained in that video in this video also. Understood? So that's why I am suggesting to watch that video before coming to this solution video. Okay, now I am explaining the solution. Keep focus guys, keep focus, because the explanation is some bit tricky in the middle part and rest of the part is very easy. Okay, so let's say I am having a linked list 10, 20, 0, 5, 3, 4, 6 and 7. Okay, this is our linked list. Our range is in between. Our range is k equals to 3 to 6. 3 to 6. Okay, and our indexing is starting from 1. So 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so we can see that 0 to 4 will get reversed. 0 to 4 will get reversed. Okay, but how we have to reverse? We don't know. So when I saw this question for the first time, what I needed, I have to reverse this part. I know I have to reverse this part. Okay, I can reverse this part easily. I have explained in previous video also. I will use add first function. I will explain in this video also. But wait for some time. 0, 5, 3, 4. I have to reverse this. Okay, so I will fail. I will having a faith that this will reverse. This will get reversed. So 4, 3, 5 and 0. I got the reverse linked list. I got it. Okay. What I have to do, if somehow I can connect this 20 with 4 and 0 with 6. Somehow, if I can connect 20 with 4. So to connect 20 with 4, what I needed? I need a pointer at this position and at this position. Okay, I needed a pointer at this position and this position. So 4 pointers are required. Okay, so I will name this temporary head, temporary tail, because this is the head of this linked list, this is tail of this linked list, and this is just previous. JP means just previous node from that range, and 6 is simply current. Okay, when current will reach just after, basically what current is the node, a pointer which is traversing the linked list. Okay, and whenever current will come out of the range, I will do this work. What is the work? To connect JP with TH, TT with current. Okay. So this is what I have to do. I will come to this part. This part will look exactly same. Okay, I will come to this part. Firstly, let me write this linked list again. Okay, I will come to this part. My answer will exactly look at this position, then I will explain you what I have to do further. Okay, I will explain for this linked list. This is exactly same. Okay, now let's say I am having a linked list. I am having a linked list 5, 6, 7 and 8. Okay, I am having this linked list. I need to reverse this. So basically we have seen so many ways. Either we can switch the pointer. When 8 will point 7, 7 will point 6, 6 will point 5. This linked list will get reversed. This is one way. But I am going to use add first node way. Okay, so what that way will do? Okay, so current is here. Okay, current is traversing this linked list. Okay, so current is 5. Now what I have to do? I have created temporary head, which is null, and temporary tail, which is also null. Okay, as I explained in that first linked list. Okay, now current is present here. What I will do? I will pick this 5. I picked this 5. I will save the next node of 5 because I am going to do something. I will save the next. So save is present at 6, and then I will put null on the next of 5 so that 5 will get separated from all of the nodes. I want to separate 5 from all the nodes. So what I will do? I will put null in the next of 5. So this point is closed. So 5 will get removed from this linked list, and current is pointing null. So we are having 5. So what 5 will do? I will put 5 into add first node function. What that function will do? That function will place temporary head and temporary tail at their perfect position. So when I pass this node, so initially there is no node, that's why both of these are pointing null. But when I pass 5, so temporary head will be present here and temporary tail will also present here, because when you are having a single node, then head is also same and tail is also same. Okay, now remove this null and current. Now current, I have to traverse the linked list using current. So current will be placed at the position of save. So current will be placed here. Oh, that's good. We have done our work for one node. Okay, now the value is 6. That's okay. I will save the next pointer of 6. So save is present at 7. Just pick up this 6 and put null on its next. So this will be removed. This is removed. Okay, now what I have to do? I will pass this 6 to add first node function. So this node will be passed there. So I have to append this 6 in front of 5. So 6 will be appended in front of 5. And what I will do? I will put temporary head here and temporary tail here. Understood na? I will pass 6 to that function. What that function will do? That function will place temporary head and temporary tail to their perfect position and append this 6 in front of that linked list. So 6 is appended in front of that linked list. Temporary head is here, temporary tail is here. Okay, now current is pointing 6. I don't need 6. I will come to 7. Okay, just remove this. I will come to 7. Okay, now just remove this. Okay, so now I will pick up 7. So 7 is picked up. So just put save in front of 7 and pick up 7. Just put null in front of it. So this is removed. I will pass 7 to this function. What this function will do? 7, 6, 5. This function will return me this, and temporary head will be here, temporary tail will be here. That's cool. Again the same process. Again. Just remove this and place current at the place of save and just place save in front in the next. Okay, so current is pointing 8. So I will pick up 8 and pass to that function. So 8 will be here and temporary head will switch its position. Okay, now this 8 will be removed. This 8 is removed and current will switch its position from current to save. So save is pointing null. Current is also pointing null. I have traversed the linked list. And what I got is this. I got this 8, 7, 6 and 5. I got 8, 7, 6 and 5. Okay, temporary head is at perfect position, temporary tail is at its perfect position. Okay, okay, so exactly same. Let's say I am having a linked list, exactly same. Okay, I am having a linked list 3, 4, 5, 6, 7, 8, 9 and 10. I am having this linked list. Okay, what I have to do, I have to reverse from 3 to 6, means 3, 4, 5 and 6, 5, 6, 7, 8. We have seen how to reverse them, we have seen. Okay, so I will start the perfect explanation. Okay, so basically initially current is present at current yeah, initially current is pointing 3, and just previous is pointing null. Just previous means the initially it is null. Okay, because the node before current is null. Okay, now current will check. Let me write the indexing. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we are very near about our solution, so just focus. Okay, why it is not switching? Yeah, okay, now JP is null. Initially this is null, current is here, so I will check whether I am in between the range. No, index value is 0, index value is 1, sorry. Now I will switch current from this position to this position, and index value will increase by 1, so index value is 2. Now JP will not remain null, JP will be placed here, After that, again current value will get switched, so it will move to next. JP will also move it to its next. Understood na? JP will move to its next. Okay, now the index value is 3. Now I am in between the range, I am at the starting index. So what this will do, I will create a while loop which will reverse this part, and this part will provide me what this part is going to provide me. This part is going to provide me this part. So 8, 7, 6, 5, temporary head, temporary tail. Understood? When I reached at the starting point, when my index is equals to the starting point, I have called that function. I have created a while loop which is going to return me this. So I got this. Now when current will get increased, so in the while loop I was increasing the current value, so current value will reach here. After completing that while loop, current value will get reach here. Okay, because you can see now in this case current is getting null, but in this case we are having some node just after the last index value. That's why current will place at this index. Okay, that's cool, very cool. So this is what I need. This is the condition where I have to get my answer, because you can see this is exactly same condition. I got a linked list, temporary head is here, temporary tail is here, current is here, JP is here. Okay, and you can see I got a linked list, temporary head, temporary tail, current is here, JP is here. I got my answer. How? I will simply point JP to TH, TT to current, and then I will simply get my answer. Understood na? What I will do, I will simply point the next pointer of JP with temporary head, and temporary tail will point current, and I will get my answer. Okay, so this is the whole explanation. Let me write the code. As I said, whatever I said, I will write that. Okay, whatever as in the sequence, I am going to write all the code. So firstly, I will create 2 pointers. So temporary head, so easy. After that, temporary tail, easy. Then I have to create a function, add first node. Okay, this function is created. Now just pass a node to this function, and what this function will do, if the temporary head is null, what this null is representing, that no node is present at temporary head. So what this will do, this will place temporary head and temporary tail to that node. We have seen that condition. So temporary head equals to node, not in else, it is in if. So temporary head equals to node and temporary tail equals to node. Simple. If this is not true, then we have to put that node in front of the linked list. So node dot next should be equals to temporary head, and temporary head should be present at node. Understood now what we are doing? We are putting that node and just putting the next pointer of that node to temporary head and just placing the temporary head to its perfect position. Okay, this is cool. Now we got to the main function. Okay, now what we have to do? Okay, now first we will create current, which will traverse the whole linked list. Okay, and we will create another node which is just previous node, or simply just previous, which is initially null. Initially it is null. Okay, and we have to keep track of index also. So int index equals to 1. Okay, now we will move until our current doesn't becomes null ptr. Understood? This is a very common condition for traversing the whole linked list. Now what we have to do, we will check whether we are in between that range or not. Okay, so if we are in between that range, then index value. Okay, so let's change this n and m. Okay, so I'm just making it easy conventional. So when the value of index is in between m and n, so what I will do, I will write if index value is greater than equals to m, and index value is lesser than equals to n. If this is true, okay, here is m and here is n. Okay, just let it be. Okay, so and if index value is greater than equals to n and lesser than equals to m, if this is true, that means I am in between that range. So I have to create a while loop while index is greater than equals to n and index is lesser than equals to m. While this is true, what are the actions I have to do? What I was doing, I was picking up the node, I was saving its current let me explain it again. What I was doing, I was picking up a node, after that saving the next node. Okay, making its next as null, passing it to function add first node. Okay, after that what I was doing, I was shifting current to next. This is what I'm going to do. Basically I am reversing the linked list. So what I will do, simply first process is to save the next, which is current.next. So I have saved. After that, what I have to do, I have to place null on its next. So current next should be equals to null. Easy. Then pass this node to that function. Okay, and just shift current to its next position. After that, increase the value of index. Okay, index. I have increased the value of index. Okay, so this part is for the range. This part is for the range. Now when we are out of the range, then what we have to do, if we will check if index is greater than m. If index value is greater than m, that means we are outside the range. Then what we have to do, we are putting jp.next as th and tt.next as current. What we are doing, just previous.next as th and tt.next is current. Okay, we have seen in the figure what we are doing, and simply return head because we are outside the range, we have to return. But if we are not outside the range, we are not in the range, what we have to do, that means we are before the range part. In that part, we have to simply increase the index value and simply shift the current pointer. Shift the current pointer and before shifting current, just place just previous at this position. Just previous at this position. Understood what we are doing? Basically, when let's say current is here, so JP is null. Easy. If current will be here, if current is pointing 20, then JP should remain at 10 na? So current will say I am leaving this place, you can hold this place. I am leaving this place, you can hold this place. This is what JP is doing. JP is holding this position and current is leaving his position. Okay, after that simply return head. Okay, now we have written the code, but one thing is missing. What is the missing case? Okay, this is a very tiny case. Let me explain that also. Let's say 1, 2, 3, 4. This is our linked list. Range is 1 to 2. That means 1, 2, 3, and 4. We have to reverse this part. Okay. Now, JP is initially null. Current is here. So current is in between the range. So what this will do? This will return 2, 1. Temporary head will be here. Temporary tail will be here. And then current will be moved to here. Now what we will do? What we are doing? Previous dot next as temporary head, but it is null. So null dot next will provide us a null pointer exception. So we have to check here. If just previous equals to null PTR, that means it is null. So if it is null, or I can say if it is not null, then we have to do this task. Else if it is null, then what we have to do? Just think about it. I am giving you 2 minutes. If it is null, then what we have to do? What we are going to return in this case? What should be our head value? I am providing you the hint. What is the value of head? Because in this case, just previous is null. We know just previous is null. We cannot do null dot next. So we have to do something else. Okay. So I think you have discovered what is the fact. The fact was we are returning head. Head is present here. If we will return head, then what we will do? Basically temporary tail is pointing current. So our new linked list will be, just remove this. We are not doing this because temporary previous is null. So what will be our new linked list? We are returning head. So head is pointing to this point. So we will get 1, 3, and 4. But we are required to return 2. So what we will do? We will put head to temporary head position. Basically, I will explain it again. It's, let's say, previous is null. So previous is null indicates that you have to start reversing from the first position. And when you are starting from the first position, the position of head will get changed. And to switch the position of head at its right position, we will write head equals to temporary head. Understood? We have to return 2. So head should point to 2. Okay. So just write here temporary head, not temporary head equals to temporary. Understood? So let's run the code and check how many compilation error we got. 24. Okay. 24. Okay. After that, more compilation errors. Yeah, 100. So 100. Okay. This is not compilation error. Here will be X and X. Understood? Because we have declared N already. That's why we will take X or any other variable. Okay. So now our code is accepted. So I hope you guys understood what we are doing. We are doing our work for in between the range, previous range, and after range. Okay. As quick as we move just after the range, we have to return our answer. We have to return the starting point, which is head. Understood? So I hope you guys understood. This problem is little bit tricky. I want you to see the video again if you are not able to understand it in one go. Okay. So we will meet in the another video. Until then, bye.